Here is the problem. We are given a block diagram with 4 transfer functions f1, f2, f3, and f4. Let me describe the diagram. The input U enters a summing junction with negative feedback. From there, the signal goes through f1. After f1, there is a second summing junction where the disturbance D enters from above. After this junction, the signal goes through f2, then through f3, and the output is Y. The feedback path takes Y, passes it through f4, and sends it back to the first summing junction with a minus sign. Our task: transform this into the simpler form shown in Figure 2. In that form, U goes through G1, then a summing junction where D enters, then through G2 to produce Y. No feedback loop in the target form. We need to find G1 and G2. Before we start, let us recall the block diagram rules we will use. Rule 1. Series connection. 2 blocks in a row multiply. G1 followed by G2 gives G1 times G2. Rule 2. Negative feedback. A forward path G with feedback H gives G over 1 plus GH. And we will also use a third technique, writing the system equations directly and solving for the output. These tools are all we need. Step 1. Combine F2 and F3 in series. Looking at the diagram, F2 and F3 are directly connected, one after the other. By the series rule, we can replace them with a single block equal to F2 times F3. Now our diagram looks simpler. U goes through a negative feedback summing junction, then through F1, then through a summing junction where D enters, then through the combined block F2, F3, and out as Y. The feedback from Y still goes through F4 back to the first junction. Step 2. Write the system equations. Let us label the signals. At the first summing junction, the error signal E equals U minus F4 times Y. After F1, the signal is F1 times E. At the second summing junction, we add the disturbance, so the signal entering F2, F3 is F1 times E plus D. The output is Y equals F2, F3 times the quantity F1, E plus D. Now substitute E equals U minus F4Y. We get Y equals F2, F3 times the quantity F1 times U minus F1, F4Y plus D. Expand. Y equals F1, F2, F3, U minus F1, F2, F3, F4Y plus F2, F3, D. Move the F1, F2, F3, F4, Y term to the left side. Y times the quantity 1 plus F1, F2, F3, F4 equals F1, F2, F3, U plus F2, F3, D. Step 3. Factor and identify G1 and G2. From our equation, Y times 1 plus F1, F2, F3, F4 equals F1, F2, F3U plus F2, F3D. Notice that F2, F3 is a common factor on the right side. Factor it out. Y times 1 plus F1, F2, F3, F4 equals F2, F3 times the quantity F1U plus D. Divide both sides by 1 plus F1, F2, F3, F4. We get Y equals F2, F3 over 1 plus F1, F2, F3, F4 times the quantity F1, U plus D. Now compare this with the target form. Y equals G2 times the quantity G1, U plus D. By matching terms, G1 equals F1. G2 equals F2, F3 divided by 1 plus F1, F2, F3, F4. That is our answer. Let us recap. We started with a block diagram containing F1, F2, F3 in the forward path, F4 in the feedback path, and the disturbance T entering between F1 and F2. In 3 steps, we found G1 and G2. Step 1. We combined F2 and F3 in series to get F2, F3. Step 2. We wrote the system equations and solved for y. Step 3. We factored the result and matched it with the target form. Final answer. G1 of S equals F1. G2 of S equals F2 times F3 divided by 1 plus F1, F2, F3, F4. 2 rules, 3 steps, done.